One of my very favourite lessons to teach is the conduction system. And therefore, let's start at the beginning. What is it? It's about the stimulation of the heart. Okay, and by stimulation, of course, we're talking about the electrical stimulation of the heart. How the heart actually goes about being stimulated to contract, to produce force, to eject blood from those ventricles, or indeed how it manages to relax, go through diastole and receive blood into those atria. That's what we're interested in today. And we've started with a very comprehensive image, actually. You could probably get a lot done with that image all by itself. But I want to start this story at the beginning. And that beginning is here with our number one, our sinoatrial SA node. And here is that fellow right there. We have a sinoatrial node. Please recognize that the sinoatrial node sits above the right atrium, okay, and this is the start of our story. Above the right atrium, the sinoatrial node, it's what we know as a myogenic structure, in the sense that it's self-regulating. You guys, of course, will be studying in other tutorials how neural control and hormonal control occur, but effectively it regulates itself. It's what we call a pacemaker. Okay, that's a term you've probably come across previously. It literally sets the pace. And it emits a signal, okay? And we're going to have a look at the nature of that signal in a second. It emits a signal, okay? So it sends a signal out. And what it does is that signal crosses the atria, okay? So that signal crosses the atria. Remember, the atria is the plural of atrium. And it causes atrial systole. Atrial systole. So let's see if we can just draw on some of those points and see if we can address this. So the SA node, it emits a signal. And there goes that signal across the atria. It's also going around here. It's also going around here. And notice that effectively what it's doing is it's contracting. It's contracting the atria in that case. So we get contraction here. We get contraction here. And of course, what do we get? We get atrial systole, the forcing of blood down into the ventricles, because the atria themselves are contracting. They're going through a phase. Now, the second thing, and this is really where we get to, and we can actually put that in here, guys. This is kind of point 2 of our stage, impulse to left atrium. So, of course, we get that atrial systole. But what we're going to get now is we're going to get stage 3 of this cycle. Okay, so stage 3 of this cycle, we've got the atrioventricular, or the AV node. Now, this is a node here. Now, not surprisingly, the AV node, where does it sit? In between the atria. In fact, let's put this in here. It is between atrium ventricles. And you'll see here that the actual AV node is just between the two. So it's sitting just at the bottom of the atria, just at the top of the ventricles there. And of course, what this will do is it will receive the signal from the SA node, okay, from the SA node. So notice that the SA node is not only stimulating the two atria to cause atrial systole, it's also stimulating this second node, which is going to perform a different function. And that function is it's going to relay the signal. Okay, so effectively, this AV node receives the signal here, look, and it's going to relay it to here. Okay, so there's our relay of that signal. So think about the job of the sinoatrial node for a second. Yes, it's to cause atrial systole, but it's also to stimulate the AV node, which of course is then going to go on to stimulate the ventricles. The other point I want to make is that I've been saying to you so far, of course, atrial systole in that sort of phase 1 to 2, right? Well, notice that during that atrial systole, we also get ventricular diastole, okay? In other words, as the atria are contracting, the ventricles are relaxing. Now we're going to get to the ventricles contracting. So we've got this new signal. The signal has been emitted by the atrioventricular node. It's now passing centrally into the septum. Now notice this structure here. I'm actually going to get rid of this arrow. This structure here, this whole area here, that area there, that is what we call the septum. I'm going to get rid of those arrows. That is what we call the septum. And you'll notice that the signal arrives here at point number 4. And this point number 4 is called the bundle of His. Now this is positioned in the septum. Positioned in the septum. And you can see that on the image there. And what this bundle of His is going to do, let me just give a little bullet point, position the septum, it's going to separate the signal, which of course is a single signal at this point, separate the signal into left and right branches, signal into left and right. So I'll just put L and R. So can you see here that effectively what's happening in our bundle of his is that we're now going to move to the next phase of this, which is where this signal is going to pass down. It was meant to be a different color. Is going to pass down as two separate signals on left and right. Now this is the exciting bit. Notice that these signals pass down the septum and then up and around the ventricles. Why? Why would that be the case? And the answer to that, of course, is that what these ventricles have to do during systole is contract this way and this way, squeeze inwards and upwards. Why? To force the blood out of the pulmonary artery, to force the blood out of the aorta. So they have to force upwards and outwards. That can only be achieved by some specialist fibers, which we're going to say are 0.5 of our system, called, what I refer to them at least as the Purkinje fibers, sometimes spelled the Purkine fibers. And what these fibers do is they spread the signal. They spread the signal to every muscular cell. In this case, of course, cardiac muscle. So that now is going to surround the ventricles, cause the ventricles to go through systole, squeeze upwards and outwards. And those myocardial cells are going to contract. Now notice this word, every. Now this relates to our all or none law. The heart contracts fully or not at all. Remember that our heart, it either contracts entirely with full force or not at all, and that's called the all or none law. And we're going to look at that at a few occasions actually as we progress through these lessons. But the other thing I want to stress here is that it's this that causes ventricular systole. Ventricular systole. We've got here systole occurring because the Purkinje fibers have spread the impulse to every cell, and therefore the ventricles move up and in, squeezing the blood out and up the heart via the pulmonary artery and the aorta on the relevant sides. Now, obviously, when we've got ventricular systole, what else is happening? We have atrial diastole. Now, this, of course, is now linking to our cardiac cycle, but just remind yourself, but for this blood to get forced up and out, these atria actually have to be relaxing at this phase. So it's worth sort of realizing at this point that we've now we have got a two-stage contractile phase of the heart itself. We have got the atrial systole, which is simultaneous with ventricular diastole. We then got ventricular systole, which is simultaneous with did I get that over? Ventricular systole, which is simultaneous with atrial diastole. Why is that so hard to say one after the other? Okay, so that's really important. These phases, these features, and these roles are ultimately where you need to get a good understanding and connection to this topic area. I hope that helps. Cheers.